This lesson, we will continue with our study of polynomial functions by developing the skill for dividing a polynomial expression by a binomial factor. This is something you have already done in a pre-algebra course or in college algebra. We need to review that because we will be using it as we move on. Alright, let's divide the polynomial 4y cubed plus 10y squared plus 7y minus 8 by y plus 3. What is the mechanism? How do we go about doing this? To begin with, we will write the function like this. The normal way we divide a number by another number. Then we have a horizontal line and a vertical line. And write this binomial factor, and next you see the first term in the binomial factor is y, and the first term in the polynomial expression is 4y cubed. Now divide this 4y cubed by y. What do you get? 4y cubed divided by y is 4y squared. Write that 4y squared, write it over here. So write the 4y squared directly above 10y squared. Now, in the next step, multiply this 4y squared with each of these terms. 4y squared times y is 4y cubed, and write it below 4y cubed. Now, always the term that you write below the first term will be exactly the same. So 4y squared times y is 4y cubed. 4y squared times plus 3 will be 12y squared, and write it below 10y squared. And now subtract the bottom term from the top. 4y cubed minus 4y cubed is 0. 10y squared minus 12y squared is negative 2y squared, and write it below the y squared term. So that will be 0 minus 2y squared. Just like you divide normal numbers, now bring down the plus 7y. And we continue what we were doing here. Negative 2y squared divided by y. What is negative 2y squared divided by y? That will be negative 2y. Now write negative 2y over here. And now multiply that negative 2y with each of these terms. Negative 2y times y is negative 2y squared, and write it below the negative 2y squared. Negative 2y times 3 is negative 6y, and write it below 7y. And now, again subtract. Subtract the terms below from the terms above. What do you get if you subtract negative 2y squared from negative 2y squared? You get 0. Now, subtract negative 6y from 7y. What does that give you? Look at that. 7y minus negative y, and that will be 13y. Alright, what is the next step? Bring down the negative 8 and repeat the same procedure. Now, 13y divided by y. Always the first term divided by the first term of the factor. 13y divided by y is 13, and write it to the right of 2y. And multiply now. 13 times y is 13y. Write it below the 13y. 13 times 3 is 39, and write it below negative 8. And what's the next step? Subtract. Alright, 13y minus 13y is 0, and negative 8 minus 39 is negative 47 and write it below the 39. And what is the answer? When you divide 4y cubed plus 10y squared plus 7y minus 8 by the binomial factor y plus 3, the result is 2y squared minus 2y plus 13 with a remainder negative 47. And how do we write the result? Look at the way the result is written. It is 2y squared minus 2y plus 13 minus 47 over y plus 3. I actually did one like this with you about 2 lessons ago. Now, this skill is important for us to divide a given polynomial by a binomial factor. All right, we're going to see a quicker way to do this in our next slide. We're going to call it the synthetic division. The synthetic division is an easy way to do the long division. It's much easier. All right, let's practice that. What is the synthetic division? We can make the process of long division much simpler by using synthetic division. In fact, once you understand synthetic division, you will never go back and do what we did just now. All right, the first step, write the coefficients of each term of the dividend along a line. Now, this is the dividend, is that right? The quantity that is divided is the dividend. And y plus 3 is the divisor. So write the coefficients of each term, that is 4, 10, 7, negative 8 along a line. So I have the coefficients 4, 10, 7 and negative 8. What's the next step? If a term is missing, write 0 for its coefficient. For example, we have a y cubed term, and the next term is y squared, then y and a constant term. Suppose this y squared term is missing, then the coefficient of that will be 0. In fact, we must account for all the terms starting from the top. If the polynomial started with a 4th power, then the next one must be a 3rd power, then a 2nd power, then a 1st power, and then the constant number. It must go in that order. If any of these terms is missing, then you must actually use a 0 in its place. All right? So pick the coefficients of each term and write them in a line. The next step, draw a horizontal line below and a vertical line to the left, like this. It is not different from the long division we just did, but the method is slightly different. All right, so we have the horizontal line and the vertical line. Now look at the space I have left from the numbers and the line. That means I'm going to actually use this space to write something else. So use that space. Number 3, third step, write the opposite of the constant term of the divisor. Now this is the divisor, and the constant term of the divisor is plus 3. Write the opposite of that over here. Opposite of plus 3 is negative 3. So write that negative 3 there. Again, negative 3 is the opposite of the constant term of the binomial factor, that is the divisor. All right, what do we do with this now? Step 4, bring down 4 to the right of negative 3. Bring down this 4. Next, multiply 4 with negative 3. 4 times negative 3, that is negative 12, and write it below 10. All right, 4 times negative 3 is negative 12, and write it below 10. All right, what do you think we do next? We got 2 numbers here. When you did the long division, we subtracted the number below from the number above. But in synthetic division, it is made much easier. We add these two numbers. Add 10 to negative 12 and you get negative 2, and write this below the line. So this negative 2 is the sum of the two numbers above there. 10 added to negative 12 is negative 2. Alright, if you follow the pattern, tell me, what do I do with the negative 2? Multiply with the negative 3. Alright, multiply this negative 2 with negative 3, and that is 6. Where do we write it? We write it below the 7, and that's the way. So 10 added to negative 12 is negative 2. Negative 2 multiplied by that negative 3 is 6. Write it below the next number, 7. What is the next step? Add 7 and 6, you get 13, and write it below the numbers 7 and 6. And I'm sure now you can tell me, 13 is now multiplied by negative 3, you get negative 39, and write it below negative 8. There you are. Okay, what do we do now? Add negative 8 and negative 39, we get negative 47. You see, isn't this simpler than what we did earlier? In fact, this is the same polynomial we divided by the same binomial. And so how do we pick the result now? So the highest power of the dividend is 3. The highest power of the dividend is 3, and we are dividing it by a binomial. That means what will be the highest power of the result? The highest power of the result will be therefore 2. Now, the coefficients of the term of the answers are, the coefficients of the terms are 4, negative 2, 13, and negative 47 is the remainder. So the result will be an expression of power 2, and the coefficient of the first term will be 4, the coefficient of the second term will be negative 2, the coefficient of the third term will be 13. So what is our expression? Our result is 4y squared minus 2y plus 13. Now this is the result, and the remainder is negative 47, and we write it as negative 47 over y plus 3, giving us the result 4y squared minus 2y plus 13 minus 47 over y plus 3. And this is quite a neat way to do the long division. Now I want you to go through this one more time and practice these steps on your own. Alright? But there is a snag here. This method works best only when the coefficient of the divisor is 1. Now here the coefficient of the divisor is 1. Now it's easier when the coefficient is 1. It will work also when the coefficient of the divisor is not 1. If anybody can suggest to me what we do, well, I will give you some extra credits for that. If the coefficient of the divisor is not 1, it is a number like 2, 3, or 4, what can we do? Okay, let's try another one. Use synthetic division to do x to the power of 4 minus 16 divided by x minus 2. Alright, tell me, what is the first step that we do? The first step that we do will be pick the coefficients of the dividend. Now the coefficient of x to the 4 is 1, and you see the term in x cubed is missing, so we use a 0 there. The term in x squared is missing, we use a 0 there also, and the term in x is missing, we use a 0 there also. Then constant term is negative 6. So what are the numbers that are going to come on a horizontal line? It will be 1 0, 0, 0, negative 6. All right. Now, the terms in x cubed, x squared, and x are missing. Therefore, we use zeros for the coefficients of those terms. And so, the coefficients are 1, 0, 0, 0, negative 16. What is the next step? Next step is you have a horizontal line and a vertical line, and to the left of the vertical line and below the horizontal line, write the number that is opposite to the constant term of the divisor. This is x minus 2. So the number you will write here is plus 2. Okay, what is the next step? Bring down the 1. Alright, and what do we do with this 1? Multiply this 1 with this plus 2. It'll give you 1 times 2 is 2. And where do you write it? Write it below 0. That's right. And the next step, add these two numbers. 2 plus 0 is 2. And what do we do with this 2? Multiply this 2 with this plus 2. And that will be 2 times 2 is 4. Where do we write it? Go to the next one and write it below the 0. That's 4 there. And now add these two. 0 plus 4 is 4. What do we do with this 4? Multiply this 4 with positive 2. That will be 4 times 2 is 8. Write it below the next 0. Alright, add these two. 0 plus 8 is 8. And multiply this 8 with positive 2. 8 times 2 is 16. And write it below negative 16. Add those two. And you get 0. What does this represent? It tells you that the remainder is 0. That's right. What does that mean, the remainder is 0? When the polynomial x to the power of 4 minus 16 is divided by x minus 2, it does not leave a remainder. It means x minus 2 is a factor of that polynomial. So, what is the result of dividing this polynomial by this binomial factor? You can see the highest degree of the polynomial of the dividend is 4. That means the highest power of the result will be 3. So you can start here. It will be 1x cubed plus 2x squared plus 4x cubed plus 8x, and the remainder is 0. So you have 1x cubed plus 2x squared plus 4x plus 8, and that is the result. X to the power of 4 minus 16 over x minus 2 is x cubed plus 2x squared plus 4x plus 8. There is no remainder. No remainder means x minus 2 is a factor. Is that right? Can you tell me, can you factor this? X to the power of 4 minus 16. You can do it in your mind using a squared minus b squared form. This is x squared minus 4 times x squared plus 4. And x squared minus 4 can be factored as x minus 2 times x plus 2. You see? So x minus 2 is a factor, x plus 2 is a factor, and x squared plus 2 is also a factor of this. Okay, let's move on. The best way to find the zeros of a polynomial is to factor the polynomial. Is that right? If you can factor the polynomial and set each factor to 0, that is the best way to find the zeros of a polynomial. That means the term that we just talked about, x to the power of 4, can be factored like I told you. What are the factors? Alright, I just showed you that x to the power 4 minus 16 can be factored as x minus 2 times x plus 2 times x squared plus 2. Now, if we can factor a polynomial like this, the zeros of the polynomial can be found by setting each factor to 0. Now, if you set x minus 2 to 0, what do you get? X minus 2 equal to 0 gives you x equal to 2. So, x equal to 2 is a 0, means if you put x equal to 2 here, the polynomial will become 0. The value of the polynomial will be 0. Is that right? X equal to 2. For example, what is 2 to the power of 4? 2 to the power of 4 is 16. 16 minus 16 is 0. Similarly, you set this factor, x plus 2 equal to 0. You get x equal to negative 2. That is another 0 of the polynomial. Negative 2 to the power of 4 also is 16. 16 minus 16 equal to 0. How about this? X squared plus 2 equal to 0. Can x squared plus 2 be equal to 0? Well, if you understand this, if you write x squared plus 2 equal to 0, it means x squared equal to negative 2, which cannot be. The square of a quantity cannot be negative. That means there are only 2 zeros for this polynomial expression. That means if you draw a graph of this, how many places will the graph cut the x-axis? At 2 places, namely, what are the places? X equal to 2 and x equal to negative 2. That's right. Okay. Alright, let's look at this problem. Find the zeros of the polynomial f of x equal to, this is a polynomial function, f of x equal to x cubed plus 7x squared minus 4x minus 28. Well, if it is possible, can you factor it? Well, factoring this may not be a simple thing for you, is it? Alright, let's try and factor this mentally. Now, follow this carefully. Now, we can do it factoring by grouping. Take the first 2 terms. What is the common factor there? The common factor is x squared. So, if you cannot keep this in mind, write it down. If you take x squared common, it will be x squared times x plus 7. Is that right? And then from the last 2 terms, take a negative 4 out. That will be minus 4 times x plus 7. And then x plus 7 is common. It will be x plus 7 times x squared minus 4. And x squared minus 4 can be factored as x minus 2 times x plus 2. So x cubed plus 7x squared minus 4x minus 28 is x plus 2 times x minus 2 times x plus 1. Alright, we have factored it. Now, in order to find the zeros of this polynomial, we set the polynomial to 0. In other words, x plus 2 times x minus 2 times x plus 7 equal to 0. And now, we set each factor to 0. When you put x plus 2 equal to 0, it will give you x equal to negative 2. X minus 2 equal to 0 will give you x equal to 2. And x plus 7 equal to 0 will give you x equal to negative 7. That means there are 3 zeros for this polynomial function. What does that mean, there are 3 zeros? There are 3 values of x which makes the value of the polynomial 0, or the graph of this function will cross the x-axis at 3 different points. So that means since x plus 2 is the factor of this polynomial, if you divide the polynomial by x plus 2, there will be a remainder 0. Now, try this on your own by using synthetic division. That would be a good way to practice it. Now, in the same way, if you divide the polynomial by x minus 2, again, the remainder will be 0. Try this on your own. And if you divide the polynomial by x plus 7, again, the remainder will be 0. Alright? Now, there are 3. Divide the polynomial by x plus 2, x minus 2, and x plus 7, and use the synthetic division to try those so that you can practice that method. Alright, let's try this one. X cubed plus 7x squared minus 4x minus 28 divided by x plus 7. Well, we know x plus 7 is a factor of this polynomial, so we expect to get the remainder 0. Alright, what's the first step in using this synthetic division? Write the coefficients of each term. So that'll be 1, 7, negative 4, negative 28 along a line. And then we have a horizontal line and a vertical line. And what is the number that we are going to write to the left of the vertical line and below 0? It will be the opposite of this constant number, that will be negative 7. Alright, what is the first step in doing this synthetic division? Bring down the first number and then multiply this number with negative 7. That will be 1 times negative 7 is negative 7. And then add these two numbers. There you are. Multiply this number with negative 7. 0 times negative 7 is 0. Write it below negative 4. Add the two numbers. It will give you a negative 4. Multiply negative 4 by negative 7. That will give you positive 28. And write it below negative 28. Add the two numbers. That will give you 0. Now, this tells you that the remainder is 0. Now, what's the result of this division? Because the highest power is 3, the highest power of the result will be 2. So that will be 1x squared plus 0x minus 4. That's right. Now, that brings us to a very important result here. And watch this. When a polynomial is divided by a binomial, if the remainder is 0, then the binomial is a factor of the polynomial. This is called the factor theorem, a very simple statement. When a polynomial is divided by a binomial, if the remainder is 0, then that binomial is a factor of the polynomial. Okay, I have repeated that over here again. Now, let's put down a couple more of these to make sure you understand it. If x plus 2 is a factor of a polynomial, then x equal to negative 2 is a 0 of this polynomial. Is that right? If x plus 2 is a factor, then x equal to negative 2 is a 0 of the polynomial. We just showed that earlier. Similarly, if x minus 2 is a factor of the polynomial, then x equal to plus 2 is a 0 of this polynomial. If x plus 7 is a factor of a polynomial, then x equal to negative 7 is a 0 of this polynomial. Alright? Let's now write down the factor theorem. And what is that? If x equal to r is a 0 of the polynomial p of x, then x minus r is a factor of p of x. In other words, look at this here again. If x equal to negative 2 is a 0, then x plus 2 is a factor. If x equal to plus 2 is a 0 of the polynomial, then x minus 2 is its factor. If x equal to negative 7 is a 0 of the polynomial, then x plus 7 is a factor of that polynomial. Similarly, if x equal to r is a 0 of the polynomial, then x minus r is a factor of that polynomial p of x. This is called the factor theorem. An important result, keep that in mind. Let's now look at what is called remainder theorem. Remainder theorem. Now, do you remember the first polynomial, we divided it by a binomial, we got a remainder. It was, what was it, negative 47? All right, look back and see if that is correct. We will use that to obtain the remainder theorem. Well, there it is. We did this one some time ago. 4x cubed plus 10x squared plus 7x minus 8 divided by x plus 3 is 2x squared minus 2x plus 13 minus 47 over x plus 3. In other words, when this polynomial is divided by the binomial x plus 3, the remainder is negative 47. Alright, so when p of x equal to 4x cubed plus 10x squared plus 7x minus 8 is divided by x plus 3, the remainder is negative 47. Now, let us now calculate p of negative 3. What does p of negative 3 mean? The value of the polynomial function when x equal to negative 3. Now, how do you do that on a calculator? Do you know how to find the value of a polynomial like this on the calculator? Well, take out your calculator now and follow the steps that I'm going to give you. Now, type in negative 3, store x. Now, well, try and follow this step. Type in negative 3, that will be negative 3. There we go. Now, I got to turn on the calculator first. Say negative 3, and you see negative 3 on the calculator, and press store. Look at the store button above the on. Store x. X is the variable. And enter. So, x is now 3. Now, enter this function, 4x cubed. Now, watch how I do that, if you can see what I'm doing. 4x cubed, so I'll say 4x to the power of 3 plus 10x squared plus 10x squared. X variable is over there, and you can square a number like this. 10x squared plus 7x plus 7x minus 8. Did I get it right? All right. So you have now stored the value of x as 3, and now you want to find what is 4x to the power of 3. I have a, you see, I'm not wearing my glasses, so I have made an error there. It must be 4x cubed. I have put it as 9. So change it to 3. 4x cubed plus 10x squared plus 7x minus 8. Enter. What you get is negative 47. Isn't that interesting? Yes. So type in 4x cubed plus 10x squared plus 7x minus 8 and enter as I showed you, and you get p of negative 3 equal to negative 47. Right. Can you use this result to define remainder theorem? Well, look at this. When the polynomial is divided by x plus 3, we got the remainder negative 47. And we calculated the value. So, what is remainder theorem? The remainder theorem says if R is the remainder when P of x is divided by x minus a, then P of a will be equal to R. This is what we just saw on the calculator. Is that right? Alright, let's practice it one more time. Use synthetic division to find P of 4 if P of x equal to x to the power of 4 minus 10x squared plus 25x minus 2. Now, according to the remainder theorem, if this polynomial is divided by x plus 4, the remainder will be what P minus P of negative 4 will be. You see, when you divide this polynomial by x plus 4, whatever remainder you get will be the same as P of negative 4. That is what the remainder theorem says. Alright, let's use the synthetic division to find P of negative 4. How do you do that? Well, use the synthetic division with this number. When the factor you divide by is x plus 4, the number you use for synthetic division is negative 4. So, let's start with the coefficients. The coefficient of x to the power of 4 is 1. Now, if you notice, there is one term missing here. The power 3 is missing, so you need to use a 0 there. So 1, 0, the power of x squared is negative 10. The power of x is 25. The constant term is negative 2. 1, 0, negative 10, 25, negative 2. Your horizontal line, vertical line, and the number that you write to the left of this line is negative 4. Okay, let's do it now. Bring down the 1, multiply 1 with negative 4, and write it below 0. Add 0 to negative 4, you get negative 4. Negative 4 multiplied by negative 4 is positive 16. Write it below negative 10. Add these two numbers, give you 6. 6 times negative 4 is negative 24. Write it below 25. Add the two numbers, that would be 1. 1 multiplied by negative 4 is negative 4. Write it below negative 2. Add the two numbers, that would be negative 6. That means when this polynomial is divided by x plus 4, the remainder will be negative 6. Or P of negative 4 will be negative 6. If R is the remainder, this is your R, the remainder, when P of x is divided by x minus a, you are dividing, our a is negative 4, so the factor, the binomial you are dividing with will be x minus negative 4, that is x plus a. So when the polynomial is divided by x plus 4, the remainder will be negative 6. Or, according to the remainder theorem, P of negative 4 will be equal to negative 6. So P of negative 4 is negative 6. Now check this on your calculator just the same way I showed it to you earlier. Like this. Negative 4, store x, and write down the function and enter. Another one. Use synthetic division to find P of 5, given that P of x equal to 2x cubed minus 12x squared minus x plus 30. Alright, let's pick the coefficients. First of all, check if all the powers are there. Power 3, power 2, power 1, constant term. So pick the coefficients. 2, negative 12, negative 1, 30. Horizontal line, vertical line, and the number we're going to use is 5. Now, bring down the 2, 2 times 5 is 10. 10 added to negative 12 is negative 2. Negative 2 times 5 is negative 10. Added to negative 1 is negative 11. Negative 11 times 5 is negative 55. Added to 30 is negative 25. The remainder is negative 25, means that P of 5 is negative 25. Also, that means when this polynomial is divided by what? Divided by x minus a. This is your a. X minus 5, the remainder will be negative 25. That's what it means. And check it on your calculator. Another one. Now these are all the same problems. I'm doing more of these to give you more opportunity to learn by practice. Alright? Use synthetic division to divide 7x to the power of 5 minus x to the power of 4 plus 3x cubed minus 2x squared minus 5 by x plus 0.9. This time I've given you the factor by which you are dividing. That means the remainder will be P of negative 0.9. Find P of negative 0.9. You notice here the degree is 5, the power 5, power 4, power 3, power 2, power 1 is missing. So be careful when you pick your coefficients. So the coefficients are 7, negative 1, 3, negative 2, 0 because there is no x there, and negative 5. Horizontal line, vertical line, your A is negative 0.9. Alright, let's go through this quickly. Bring down the 7. Keep your calculator and do these calculations with me. 7 multiplied by negative 0.9 is negative 6.3. Is that right? Yes. Added to negative 1, negative 7.3. Negative 7.3 multiplied by negative 0.9 is 6.57. Added to 3, you get negative 9.57. Alright? 9.57 multiplied by negative 0.9 is negative 8.613. Added to negative 2 will give me negative 10.613. Negative 10.613 multiplied by negative 0.9 will be 9.5517. Added to 0 is 9.5517. Multiply this to negative 0.9. That will give negative 8.5965. Added to negative 5, it is negative 13.5965. In other words, when this polynomial is divided by this binomial, the remainder is negative 13.5965. Therefore, P of negative 0.9 is negative 13.59653. All right? Okay, so P of negative 0.9 is negative 13.5965. Now, let's do a problem on the calculator. Approximate the x-intercepts and the local extrema of P of x equal to 0.1 x to the power of 4 plus 0.2 x cubed minus 23x squared minus 23x plus 90. I want you to draw the graph of this on your calculator. You know to take an appropriate scale. I'm not going to give it to you. You got to now work out and take an appropriate scale and plot a graph. Alright, here is the graph of that polynomial function. Now you need to approximate the x-intercept. There are how many x-intercepts? 1, 2, 3, 4. and the local extremum. What's the local extremum? If you look at this, the function decreases, reaches the minimum, and then increases. This is called a local minimum. Why is it called a local minimum? Because the function can have other minimum values elsewhere. This is the local minimum. Then it increases, reaches a local maximum, decreases, reaches a local minimum, and thereafter increases. So we need to find the approximate values of the x-intercepts and the local maxima and minimum. Alright, let's find the x-intercept. Follow the calculator stroke. Now we will be using this very often. Second trace 2. That will help you to find the x-intercept. And when you do that, it will ask you for a left bound. Now this is the x-intercept you want. So to give a left bound, what all you need to do is take the cursor to the left of the point here. So take it up somewhere here. Or, as I said, type in -18 for the left bound and enter. And for the right bound, bring the cursor to here and enter. Or type in -14. And then it will ask you for a guess. Take the cursor back to where the point is and enter. Or somewhere -15. And you see the calculator will give you a 0. Remember, x-intercept is a 0. And the 0 is x equal to -15.57. And that is a 0. Alright, x equal to -15.58 is a 0 of the polynomial. That's an approximate value, not the exact value. If you look here, it says y equal to -3.7 times 10 to the -10. Y is supposed to be 0, but this is, for all practical purposes, is 0. Now you can find the other x-intercepts. Repeat this. Second trace 2, and bring the cursor somewhere here, to the left for the left bound, to the right for the right bound, and back to the point for a guess, and each time enter and find the 4 x-intercepts on your own now. Okay? Let's now find the local extremas. To find the local extrema, let's look for the local minimum. What is the calculator stroke? We have actually done that before. Second trace 3. Yes, second trace 3 is for a minimum. Now it will ask you for a left bound. So what you need to do is take the cursor to the left of the bend and enter. Then take the cursor to the right of the bend and enter. And bring the cursor back to the bend and enter. Or I have given you some values. It's always good to play with the cursor rather than trying to guess these values. Alright? It will give you this. It says minimum, look at this, x equal to -11.259, y equal to -1245.15. Which of these is your minimum value? Remember, we are looking for the function value, the y value. So this is the minimum value, -1245.15, and the minimum occurs at this x value. That's right. So a local minimum occurs at x equal to -11.26, and that minimum value is -1245.15. P of -11.26 is this. So you found a local minimum. And now find this local maximum and the other local maximum on your own. Okay, now here is an application problem. The table lists the rate of marriages in America as a percentage of the total population since 1940. Now, here 1940, the percentage was 1.111. 1950, it went down to 0.085. 1960, 1.06, and so on. Now, here we are studying the trend of the rate of marriage. Now, are more and more people getting married and establishing families, or are people simply loafing around and not bothering to get married, living together? This is the trend that you see, is that right? So it's a good thing to make a study on it. Now, what are we supposed to find? If X represents the number of years since 1950, I think we started at 1940, so we can change that to 1940. Find a cubic polynomial function that represents the marriage rate. But we're going to use the calculator to obtain a cubic function of a given data. All right, what we're going to do is we're going to make a list L1 of the X values. The X values are the years, starting 0 at 1940. That means if this is 0, this is 10, 20, 30, 40, 50, 60. And the list L2 is the marriage rate. Now, first of all, reset your calculator by this keystroke. Second, +7, enter. Then 2, enter. Let me see if I can show that to you. Now, here I have the TI-84 calculator. Watch the various keystrokes that I'm using here to obtain the data that we have to obtain a polynomial function. The first thing to do is to reset the calculator. So follow this keystroke. I have given you it in the PowerPoint. Press second plus, that takes you to the memory, and we want to reset. See, that is number 7. So press 7, and we want to reset all RAMs. So enter, and then asking you reset no, number 2 reset. Choose number 2. So press 2 where my cursor is. So press 2 and enter. The calculator is now reset. What we are going to do is to make 2 lists. List 1 for the number of years. So watch this, how I'm going to make the list. Access the menu called Start. Can you see where I'm pointing? So press Start and enter. It'll give you the list where I can enter. So enter the list values for L1. What are they? 0, enter. 10, enter. 20, enter. 30, enter. 40, enter. 50, enter. And 60, enter. And now press the right arrow to go to the next line so that we can enter the corresponding rate values. 1.11, 1.11, enter. 0.085, enter. 1.06, enter. 0.95, enter. 0.98, enter. 0.89. The next value is 0.89 and enter, and the last value is 0.9. Enter. Now you have 2 lists in the calculator called L1 and L2. What we're going to do is to do a regression calculation. So go back to Start, press Start. I hope you can see my cursor. And go right arrow once to choose Calculate. And we're going to calculate number 6, cubic regression. That's what we have been asked to do. So press 6. and we have a cubic regression written on the calculator. And look at the keystroke now. Use a parenthesis, and then we need to type in L1 there. You know where L1 is? There is L1 there. So press second 1 to get L1 on the calculator. Then we need a comma, so press comma. Then second 2 to get L2. And close the parenthesis and enter. Now the calculator will give you y equal to ax cubed plus bx squared plus cx plus d, where a, b, c and d are given. So what is our polynomial? Our polynomial is negative 2.597 x cubed plus 0.00235 x squared minus 0.0496x plus 0.92. That is our polynomial function. We have now obtained the cubic polynomial function that represents how the marriage rate changes with time. Is that right? Okay. Well, if you missed those steps, again, reset your calculator by second plus 7, enter, then type in 2, enter, and then start, enter, to get the screen, and type in these numbers. There you have the list of numbers, and then press the right arrow to go to the next screen and type in all the rate values. And then press start, right arrow to choose calculate, and press 6. That will give you cubic regression. And press second 1, second 2, and enter. That gives you the cubic regression there, and this is the cubic regression equation. P of x equal to negative 0.00025 x cubed plus 0.0023 x squared minus 0.049x plus 0.92. And can you graph this on your calculator? Put this on the graph window, y1 equal to that polynomial function, and set the correct window. Well, I have given it to you here. X minimum 0, x maximum 75, y minimum 0, y maximum 1, and there you have the cubic polynomial. The rate decreased to a minimum, then increased, and then now it is almost a free fall in the last 20 years. Find P of 70. Follow this keystroke. Press second trace 170 and enter. It will give you x equal to 70, y equal to 0.185. Now what does x equal to 70, y equal to 0.185 means? From the beginning of our study, 70 years on, that means that will be 2020. The rate will be 0.185. If the rate continues like this, very few people will be getting married, and a lot of people will be simply living together, I suppose. Well, that's, well, I've asked you, what does it mean? Can you interpret it?